Good evening. I welcome you all for today's session, Internal Circuit Diagrams of IC741. So in the previous session, we discussed about what is an op-amp, first why we are going for an op-amp, why op-amp is introduced, and what is an op-amp, function of op-amp, and the pin diagram and pin functions of op-amp. Now we are going to discuss about the internal circuit diagrams of IC741. Simply we have seen an op-amp circuit in the previous session, like with two inputs and one input, three terminal device, right? Now we are going to discuss about the entire internal circuit of circuit of IC741. See, look at the diagram. This is the internal circuit diagram of IC741. Here, see how many transistors you have. Totally we have here 10 resistance and 20 transistors. We have 10 resistance and 20 transistors, and we can see the first pin and second pin as inverting input and non-inverting input, and the second pin and third pin as inverting input and non-inverting input, and first pin as offset null, and sixth pin as output, then seventh pin our supply, fourth pin also supply. Whatever we discussed in the pin diagram, the same is given here. So this circuit diagram, instead of looking like this, we can just discuss with a block diagram. So this is the block diagram of that which is going to explain about our circuit diagram. So this block diagram consists of 4 blocks, that is double-ended differential amplifier, single-ended differential amplifier, level shifter, and impedance matching amplifier. So here this is the op-amp block diagram. We are giving 2 inputs here, like V1 and V2, and we have a differential amplifier. See, the block, under the block we have given, I have shown a circuit which consists of double-ended differential amplifier. The meaning of double-ended differential amplifier is you are giving 2 different inputs and you are receiving 2 different outputs, like VON and VO2, 2 different output voltages. Okay, this is said to be as double-ended differential amplifier. And next one is single-ended differential amplifier. Here that VON and VO2 is given to single-ended differential amplifier. You can see the next circuit diagram where your output is a single voltage as V0, right? So that V0 is given to a level shifter, which is emitter follower. So in the circuit diagram, all the input you might have been given to the collector, right? So it is a positive voltage. So in this level shifter, we are connecting to the emitter follower, and that output is given to impedance matching amplifier, which is a complementary push-pull amplifier. So with that, we can receive the output of your op-amp block diagram. This output may be connected to any source or any load, whatever needed can be connected, right? So this is our op-amp block diagram. So with this block diagram, so as I said in that circuit diagram, the 741 amplifier is made up of a circuit containing 20 transistors and 11 resistors. The inverting and non-inverting inputs are connected to 2 NPN transistors Q1 and Q2 respectively. Both the transistors behave as NPN emitter follower with their outputs fed to a pair of PNP transistors Q3 and Q4, which are configured to function as common base amplifiers. So this is a configuration, isolates both the inputs and prevents possible signal feedback that might occur. The voltage swings at the inputs of op-amp can influence the current flow in the internal circuit, and it might go beyond the active operation range of any transistor in the circuit. In order to prevent that from happening, 2 current mirrors are used here, right? So the transistor pairs Q8, Q9 and Q12, Q13 are arranged to form this current mirror circuits. So the transistors Q8 and Q12 are the controlling transistor which sets the emitter base voltage of the other transistor in the corresponding pair. So this voltage is controlled precisely down to fractions of millivolts in order to allow only the required amount of current to flow. The first current mirror formed by Q8 and Q9 are coupled to the input circuit, and the second current mirror formed by Q12 and Q13 are coupled to the output circuit. So the third current mirror formed by the transistors Q10 and Q11 has a high impedance connection between the input circuit and negative of the power supply. So at last, the transistors Q15, Q19 and Q22 are configured to work as a class A amplifier, and the transistors Q14, Q17 and Q20 form the output stage of the 741 amplifier. So to balance any irregularities at the input differential circuit, the transistors Q5, Q6, Q7 are used to form an arrangement that takes in two inputs, that is our offset null plus and offset null minus, and balances both the inverting and non-inverting inputs accordingly. Thank you.